Okay, so here is the test review for quadratic functions. The first one was complete instructions where we're basically going to create the graph of this equation here. So the first one is determine whether the graph will open up or down. So real quick, if we look at our numbers, A is 1, B is 2, and C is negative 3. Since A is positive, we know it's going to be a parabola up. Give the equation for the axis of symmetry. Remember, the axis of symmetry always equals negative b over 2a.
Sorry for the interruption. Building, please come to the clinic immediately. Ms. Lord, please come to the clinic immediately. Thank you.
And so we'll get negative 2 over 2 times 1, or negative 1. So our equation for our axis of symmetry is x equals negative 1. Then it says to find the coordinates of the vertex. But we know that the x value, the vertex, is on the axis of symmetry. So all we have to do here is plug negative 1 back into our equation. So y equals negative 1 squared plus 2 times negative 1 minus 3, or 1 minus 2 minus 3 is going to give me negative 4. Now remember that you can also get that from your calculator. If you plug in the equation in, once you find the axis of symmetry here, you can go to the table of values and find your graph. And I'm just going to double check this. X squared. And we'll get negative 1, negative 4. So our vertex is right there. Give the coordinates of the y-intercept. Well, remember, the y-intercept is always c. So the y-intercept is going to be at 0, because it's always at 0, and negative 4. And then graph the function. We can create a small table of values if we want. I already have negative 2, negative 4. I have negative 1, negative 3. If we go to a table of values, we'll see that we also get 1, 0, and 2, 5. And because it's symmetrical, if I get points on one side, I have points on the other, and there's my graph. If we want a quick review of how we get these kind of values out of our calculator, let me go ahead and pull it up, and I can show you. Just a quick review is if we put the equation in, y equals x squared plus 2x minus 3, and we look at the graph. If our graph is wrong, remember we want to zoom standard. I got my stat plot on. And if we want it to look exactly like it does on graph paper, then after doing zoom standard, we do zoom square. And the two graphs should look very similar. They do. So to get the table of values out of the calculator, what we want to do is above graph, we just go to, sorry, the smartboard seems to be a little bit off, the table of values. And we can see right there are my is my vertex. Sorry, a little bit off here with the smartboard. Right there is my 0, and we can get the other values that we need to graph off our table of values there. All right, for this one, circle the graphs where the discriminant is positive. Place a 0 through x where the discriminant is negative, and leave blank all graphs where the discriminant is 0. So basically what they're asking you to do is to link this to the number of solutions. And if you remember, if b squared minus 4ac is greater than 0, then there are two real solutions. Solutions. If b squared minus 4ac equals 0, there's one real solution. And if b squared minus 4ac is less than 0, which remember means that's negative, then there are two complex solutions. Means they contain I. So, look at this first one. It has two zeros, which means that it's positive, so we circle that one. This one has two zeros, circle that one. This one only has one zero. So that means the discriminant is 0, so we're going to leave it blank. This one here doesn't have any zeros, which means the discriminant is negative. The instructions say put an x to ones that are negative. Once again, only one zero, which means that the discriminant equals 0, so we leave that one alone. This one has two zeros, so we circle it. Right. By looking at the graph, we can tell the number of zeros, and we have to link that to the information here. The number of zeros is also told to us by the discriminant. All right, so now we get into the solving part. Remember, there are 5 ways to solve. We can take the square root, smartboard's way off, of both sides. You can factor. You can graph. Or you can, well, actually, you can complete the square. Or last but not least, you can use the quadratic formula. So the question is, which one do we want to do? So for this first one, my tip to you is to always graph it first. See if you can solve it by graphing. So it's x squared plus 5x minus 14. So instead of, what you would do is you would, to check it by graphing, you would just say y equals and put it in your calculator and look at the graph. Hold on, I need to reset the graph on my calculator here real quick. All right, and what we will see is that it intersects neatly through two integers, and so that means it's probably factorable. And if we were to look at it, we would say, oh yeah, clearly it's factorable because it's x plus 7 times x minus 2 equals 0. In which case, by the zero product property, one of these two statements must be true. In which case, x equals negative 7 or x equals 2. So my solution set is negative 7, 2. Now, if you were to graph it, those are the exact zeros it goes through as well. If we were to sketch a graph real quick, it's going to look like this. And this is 2, and this is negative 7. All right, for this one, in order to, there's 2 ways to attack this problem. We can either set it equal to 0, But because we have squared equals a number, the easiest way to do this problem is to merely take the square root of both sides. Remember, when you take the square root of both sides, one side becomes plus or minus, and we'll just get x equals plus or minus 10i. And so there are two answers, negative 10i and positive 10i. And remember that imaginary solutions always come in pairs. Always, always, always. For this one, we can try and do it graphically. But when we do that, we'll notice that they don't go through exact points. Now, we can bound the zeros and get decimal approximations, but the instructions were to find exact solutions. So I'm going to go ahead and use this as an example of the quadratic formula. A equals 1, B equals 3, C equals negative 12. The quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And don't worry, this will be on the board, and when you take the SOL, it'll be on the formula sheet. So now we just sub in negative 3 plus or minus 3 squared minus 4 times a times c all over 2 times a. Or negative 3 plus or minus the square root of 9 plus 48 over 2. Because we do the multiplication first, and so we'll get minus negative 48, which is plus 48. And we'll get negative 3 plus or minus the square root of 57 over 2. 57 can be factored down to 3 and 19. But since 19 is a prime number, we cannot reduce that radical. So there's your final answer. Or if we write it out as an answer set, it'd be negative 3 plus the square root of 57. Or actually, let's write it down here underneath. So it'd be negative 3 minus the square root of 57 over 2, and negative 3 plus the square root of 57 over 2. As a note, I'm going to go back one problem, or actually two problems here. If I had used the quadratic formula on this problem, we would have gotten the right answers. We would have gotten negative 7 and 2. It's just it would have taken a lot of arithmetic to get there. But the quadratic formula would still give us the right answer. All right, for this one, we need to set it equal to 0 first. So it's going to be negative x squared plus 6x minus 3 equals 0. And remember the algebra trick. If we move something from one side of the equal sign to the other, it becomes the opposite. So I'm going to check the graph. And when I look at the graph, once again, it does not appear to be an exact answer, so I'm going to use the quadratic formula. A equals negative 1, B equals 6, C equals negative 3. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I'll end up with negative 6 plus or minus the square root of 36 minus 12 over negative 2. And you have to be careful here. It's a negative times a negative, which will give you a positive, so it's minus 12. Now, we can reduce the square root of 24. So we will get x equals -6 plus or minus 2 times the square root of -2, or -3 plus or minus, actually let's divide everything through by -2. So that'll just give me 3 plus or minus the square root of 6. What's confusing here is that when we divide the negative, we have to divide both terms by -2. So 3 divided by -2 becomes, -6 divided by -2 becomes +3. 2 divided by -2 becomes -1, but then the negative version of it becomes positive, so the signs don't change, and there's your final answer. Or, to write it out as an answer set, it's going to be 3 minus the square root of 6 and 3 plus the square root of 6. All right, for this one, I told you a while ago that if there is no C term, then the easiest way to solve this is to set it equal to 0 and factor it. So I'll factor out an x, and I'll end up with 4x minus 7 equals 0. And then we just use the zero product property. And so my two answers are 0 and 7/4. Right, now the numbers are starting to get a little bit bigger. Now, this one can be solved by factoring. You could use the, sorry for the interruption.
Thank you.
You could use the quadratic formula here, but I'm going to do this by factoring. So just to remember our factoring, a times c is -12. So I need two numbers that multiply together to give me -12 that add up to -11. That's very clearly -12 and 1. So this is 3x squared minus 12x plus x minus 4 equals 0. Remember, we're splitting that and then factoring by grouping. So we'll get 3x times x minus 4. Can't factor anything out of this, so I'll just write a 1 out front. And I'll get 3x plus 1 times x minus 4 equals 0. And so by zero product property, either 3x plus 1 equals 0 or x minus 4 equals 0, in which case x equals 4 or x equals -1/3. So my solution set is -1/3, 4. All right, that's enough of solving. Write a quadratic function with -4 and 2 as its roots. Write the equation in standard form. Well, if -4 is the 0, then x plus 4 is the root. If 2 is the 0, then x minus 2 is the root. And those multiplied together are going to equal 0. So it said write it in standard form. Well, I just have to FOIL this out. X squared plus 4x minus 2x minus 8 equals 0. Or x squared plus 2x minus 8 equals 0. And remember, you can always double check this very easily by graphing it. And when you graph it, these had better be the zeros or the x-intercepts. For this one, give an example of a quadratic function standard form that has one real 0 at 5, 0. Well, that means the 0 is 5, which means the factor is x minus 5. If there's only one 0, that means it's coming up twice. And so I'll end up with x squared minus 10x plus 25 equals 0. And if I lost you there, I'll write out the intermediate step. But we just FOIL that out. Remember that any quadratic is going to have two zeros. So if it only has one, that means it's what's known as a double zero. All right, the height of a baseball after being hit is given by the equation h of t equals negative 16t squared plus 48t plus 2. What is the maximum height the baseball reaches, and when does this occur? And at first, oh my goodness, a word problem. But remember, this is a parabola down, and it's asking for the maximum height. So all it's really asking for is the vertex. So we just go to the equation we used earlier. X equals negative b over 2a, which in this case is negative 48 over 2 times negative 16. Or 1.5. Now, in this equation, we're going to be using t as the independent variable instead of x. So it's going to reach its maximum height at 1.5 seconds. And then I'm just going to plug 1.5 into the equation. To solve it. And you get a height of 38 feet. So the maximum height the baseball reaches is 38 feet at a time of 1.5 seconds. The length of a rectangle is 6 inches longer than its width. If the area of the rectangle is 40 square inches, what are the dimensions? Now, at first glance, this problem is like, oh my goodness, there's too much going on. So let's just break it down piece by piece. There is a rectangle. One side is 6 inches longer than the other. Well, I don't know what that means, but that means if I call this x, then this side is x plus 6. Now, how do we find the area of a rectangle? Well, it's length times width. And I know that the area, when I multiply those together, is 40. So all they're asking me to do is to solve this problem. So I get x squared plus 6x equals 40. So the easiest way to solve this is to set it equal to 0. And now I can choose any of the ways I know to solve this, factoring, quadratic formula, graphing, whatever. But what we will find is that the easiest way to do it is by factoring, is that x plus 10 and x minus 4. Now if we solve this, I get two different solutions. I get negative 10 and 4. And this is one of those interesting positions where you can't have the length of a side be negative 10. So the answer is one side is 4 and one side is 10. And there's my 40. All right. Two cars leave an intersection. One travels north, the other travels east. When the car traveling north has gone 24 miles, the distance between the cars was 4 miles more than 3 times the distance traveled by the car heading east. Find the distance between the cars at this time. All right, well, let's draw a picture. One car heads north. It's gone 24 miles. Then another car calls east, and we don't know how far that goes, so that's x. But this forms a right triangle, the distance apart, and then we know from Pythagorean theorem a squared plus b squared equals c squared. So the distance between the cars was 4 miles more than 3 times the distance traveled by the car heading east. So this one is 3x plus 4. And so now we just need to solve this. is x squared plus 24 squared equals 3x plus 4 squared. So I'll get x squared plus 576 equals, all right, so you get to FOIL out 3x plus 4 times 3x plus 4. So I'll get x squared plus 576 equals 9x squared plus 24x plus 16. So subtract x squared from both sides, and I'll get 576 equals 8x squared plus 24x plus 16. Because in order to solve it, I'm going to have to set it equal to 0. And I will get 0 equals 8x squared plus 24x minus 560. Now, at first glance, it looks like these are all really big numbers. But what's kind of cool is that all these numbers are divisible by 8. So I'm going to divide both sides by 8 just to make my life easier. And I'll get x squared plus 3x minus 70. So now I need two numbers that multiply together to give me 70 that add up to 3. Well, I think I can crack that code. That's going to be x plus 10 and x minus 7. And so my two solutions are either x equals negative 10 or x equals 7. Well, you can't go negative in one direction, or at least not in this model. So this has to be 7. So this has to be 25. And sure enough, we have one of our Pythagorean triples, 7, 24, and 25. So the question was, the distance between the cars was 25 miles. If you have any questions on this, there will be word problems on the test. There'll be 3. You'll get to choose to do 2 of them. They won't be exactly like the problems I showed here. If you have any questions, be prepared to ask them in class.